Alright guys, so this video is, I believe it's polynomial equations and factoring 5a. We are trying to factor more complicated quadratic expressions today, and eventually we're going to solve those. But today we're just trying to talk about factoring when the going gets tough. That's kind of how I've labeled it, at least, how I presented it to you. So let's look at some things, maybe some things we know, maybe some things we don't know, and let's just see how that goes. So let's look at what's going on here. So the first thing is just kind of like things that we know. So like we should know how to do this problem, right? That should be something where we're like trying to multiply to this number and add to this number, and it looks something like that. We should know that at this point. Don't go on if you don't know how to do this. Find a video that covers that. We should know how to do this problem, problem 2. And if you are looking in the polynomial equations and factoring, honestly, polynomial equations and factoring 2 and 3 are probably going to be the ones that are going to help you with this kind of stuff. So polynomial equations and factoring 2 and 3, maybe even polynomial equations and factoring. I don't know what I'm trying to say. I think what I'm trying to say is the videos that are 3a and 3b and 4a and 4b, those are the videos you want to see for this. So if this isn't going well, just take a look for those. We should be able to take out a greatest common factor, number that goes into the numbers, take out an n, know that this is a 1 parenthesis, and maybe even go further than that. I think this is 9n, and then it's like n squared. It's 7n squared minus 5n plus 2. And then maybe we can break that down further. I don't know. I don't think in this case we can. So these should all be pretty comfortable. Even this one, number 4 here, should be able to take out a 6, and then we have r squared minus 8r 12. And then this can go further. We can break it into r minus 6 and r minus 2. All right, so after a lot of difficulty, I've gotten this microphone. I'm doing a voiceover now for you. And these, we're just trying to finish up these problems and try to figure out how to do those. So now when we're looking at this right here, it starts to make us think of numbers that are multiplying to something and adding to something. And if we're looking for numbers that multiply to negative 10, think about the signs of those numbers. One would have to be a negative and one would have to be a positive. And if they're adding to 9, the bigger number would have to be the positive number, right? So multiplying to 10 would be 10 and 1. You'd need a positive 10 and a negative 1. The bigger number would have to be positive. If you're looking for numbers that multiply to negative 12, well, the bigger number is going to have to be negative if they add to negative 4, right? The bigger number will be what it adds to. If it adds to a negative, the bigger number is negative. If it adds to a positive, bigger number is positive. So now we're talking a little bit about stuff that you know how to do, but a little bit of a recap. I like to recap on each video this problem. So we know that what we need to do is set the right side equal to 0. That's step 1. So we're going to add 10 to both sides. Once we've done that, we are going to have to make sure we have it in the proper order. So we have 10 is the smallest, right? Is the smallest power. We have 5x squared plus 15x plus 10. So that's the power of 2. 15x is to the power of 1, and 10x is to the power of 0 because there's no x's there. So keep that in mind. This is standard form or descending order. And now let's look at this problem and see if we can factor the left side. That's always step 2. So the left side seems to be all divisible by 5. So if I take out a 5, I have 5x squared plus 3x plus 2 equals 0. And if you distribute, these should all check out, right? All of these things should check back out. We know that this whole thing still equals 0, and we don't want to forget that the 5 and the 0 need to be kept with this whole thing. So the 5 comes down, and the equal 0 comes down, and we work on that inside part. However, I want to show you a trick here that you might find helpful. If that 5 was divided on both sides, if you divided both sides by 5, you would cancel out the 5 on the left side because you have 5 divided by 5, which is 1. And on the right side, look on the right side, you have 0 divided by 5. And 0 divided by 5 is 0. So you can kind of clean this equation up and make it look a little bit better by dividing both sides by 5, leaving you with just x squared plus 3x plus 2 equals 0. That blue equation is something that you are pretty familiar with. Definitely something that you should be able to factor now. So you're looking for things that multiply to 2 and add to 3, 2 sets of parentheses. What multiplies to 2 is 2 and 1. So it would be x plus 2 and x plus 1, and then we would set those factors to 0. Don't forget this part. People always skip this last part. But we need to set x plus 2 equal to 0, and we need to set x plus 1 equal to 0. And we need to solve both of those purple equations. And they should be pretty quick and easy to solve. You subtract 2 from both sides over here. You get x equals -2. You subtract 1 from both sides over here. You get x equals -1. And those are your answers. You should be able to plug them back into that original top left problem there, and it will work. It will be an actual equal equation. Now, when you have two factors that are the same, you must write them as raised to the second power. Sorry if you couldn't see those words quick. There they are. So if we're looking for things like x plus 4 times x plus 4 is our answer, we need to write that as x plus 4 raised to the second power. You see that 4 and 4 multiplies to 16, and 4 plus 4 adds to 8. So if you had x times x, that'd be x to the second power. If you had 12 times 12, that'd be 12 to the second power. If you had x to the third, that'd be x times x times x. 4 squared is 4 times 4. So when you have x plus 4, or x plus 1 rather, squared, that's x plus 1 times itself, x plus 1. You need those parentheses there to get it. So just a little reminder of that. People forget it at times. So now we get into the new material, and this is where I really need your full focus. It's definitely a lot of confusion here. We're looking at these numbers and we're saying, how can I factor this? Well, factors means, can I divide all the numbers by a number? Can I take out a greatest common factor? Does 3, 10, 7, do they all divide by the same by a number? No. 10 doesn't divide by 3. They don't divide by 2. They don't all have a greatest common factor. They just don't. So the only thing you could take out would be a 1, and that's kind of useless. So we're not going to be able to pull a GCF out, and that is something that we're not happy about because we haven't been able to deal with this before. So what we're going to use is we're going to use that old school parenthesis method, 2 sets of parentheses, 2 factors, and we are going to make sure that the things on the outside and the inside have to kind of match up in a way, like foil. So I'm going to draw a couple of field goal posts here, as I like to call them. So here's my inners, and this field goal post here is going to represent my outers, and we're going to need those as we go through this problem. So let's look at what happened before. We used to say in the beginning of the parentheses was just x and x, but in this case we have 3x squared. So we can't exactly put for the red x times x. We really need 3x times x. So up here you see in the top right, I'm showing you how that's normally set up with x times x, because that's x squared. But 3x squared is 3x times x. So I need to fill in 3x times x. 3x times x is 3x squared. Then I look to the 7. I'm still looking for things that multiply to 7, and I think the only things that multiply to 7 are 7 and 1. So I'm either going to use 1 and 7 or 7 and 1 for these two numbers here at the end. So let's just go with 1 and 7 for now. So now we have 1 and 7 on those because they multiply to the blue. And when we look at the outside bracket, and I'm going to use green here to show, I need to get 10x. From my outsides I get 21x, and from my insides I get 1x. Notice those field goal posts. When I multiply 3x times 7 I get 21x. When I multiply 1 times x I get 1x. 21x and 1x are going to add to 22x or subtract to 20x. In no way are they going to add or subtract to 10x, which is what I want them to do. So 1 and 7 were not the right choices here. So we need to erase and swap them. Swap the 1 with the 7. And when we do that, we start looking at what is the inside and what does the outside multiply to. So the inside multiplies to 7x, and the outside multiplies to 3x. Well, 3x and 7x add to 10x. So if I simply add a positive 3x and a positive 7x, which would imply that the plus has to go next to the 7 and the plus has to go next to the 1, then I would get my 10x. And this would actually be my answer. So this whole entire thing up here, 3x squared plus 10x plus 7, actually equals 3x plus 7 times, factored, x plus 1. It's the same thing. That's the answer in the circle. So moving on, let's see if we can try another one. These were all positive. Now we're going to get into some negatives, and you probably won't like that all that much, but let's see what we can do with it. Okay, so this problem here is going to be a now you try. It's going to wind up being a now you try. So just keep that in mind. We're going to skip it in the interest of time because I don't want to make this video go too long. So 3n squared plus 8n minus 3, so you got a negative in there. You need things that multiply to 3n squared. So you can't take a GCF out, etc. So just try your best with that problem. I think you'll be able to get there. Use the field goal post method, okay? So, nice little meme for us here. What if algebra teachers are really pirates and they're using us to find x so they can find the treasure? That's possible. Keanu Reeves is wondering that in this meme today. So just breaking up the video a little bit. I could be a pirate that's just asking you to find x so that I could find the treasure, you know? And honestly, that's what we're building to. Finding x with an x squared. Okay, so now you try that problem, so pause the video if you need to, or just swing back at the end. I'm going to move on to the next one, because I'm trying to keep this video not super long. And it's looking like we have 2x squared minus 11x minus 21. So two things that will multiply to 2x squared. I guess that would be 2x and x. So I'm going to draw my field goal post in here in just a minute. But for now I know 2x times x is really my only option because no other integers like whole numbers or whatever you want to call them, but I like to call them integers, multiply to 2x squared. So 2x times x. Now we're looking, we don't see that 2 divides in everything, right? That's why I underlined everything in red here. Now we're looking at the 21. What multiplies to 21? Those numbers have to go at the end of the brackets, and that's in blue. So 21 is 7 times 3, or 21 times 1. We're just looking at the 21. Forget about the negative for a minute. So it's either 7 times 3 or 21 times 1. So I'm going to pick one of those. I might pick the wrong one just to give you a sense of what's happening here. Let's see what I can do here. So 21 and 1. As I build my brackets, I'm thinking about 21 and 1. If I was to take the outsides, I would get 2x. And when I was to take the inside, I would get 21x. 21x and 2x do not in any way add to 11x. They either add to 23x or they subtract to 19x. It's not going to be a good thing for us. So those aren't right. So I'm going to swap the 1 and the 21. Well, when I multiply the 1 times x, that's 1x. And the green on the outside is 42x. 42x and 1x give us 43x, or they subtract to 41x, not getting us 11x, so again a failure. So at that point I would take 21 and 1 and I would bring it to the number graveyard. So rest in peace 21 and 1. They are gone. So we'll scratch them out and we'll work on 7 and 3. And we'll either try 3 and 7 or we'll try 7 and 3. Not sure what to do, so we just go for one or the other. So 7 and 3 it is. So if we go to the insides and the insides multiply to 7x, the outsides multiply to 6x. 6x and 7x add to 15x or subtract, sorry, they add to 13x, my mistake, or they subtract to 1x. So that's not a good thing because they don't add or subtract to 11. We can't get 11 from those two green things, so I erase. And I go ahead with the 3 and the 7 swapped. So I'm going to bring the 3 over and the 7 over. And so now I'll have, let's see, I'm going to have 3x on the inside, and then on the outside, I think I'll have 14x. So in green, 3x and 14x. We want the green to add to negative 11. It does if the 14's negative, because when they subtract, they come out to 11, but only if the 14's negative, which means that the 7 must be negative, and the 3 would be positive in that case. Notice also that positive 3 times negative 7 is negative 21. So this is our answer, and we are well on our way to being where we need to be. We're addressing negatives and everything, so it's really exciting. So what is next? That's the question. Let's see what we've got. I guess really just some now you tries at this point. So you're going to try to factor these. There are 3 of them. These are the 3 now you tries you have to have. You notice this first one might be kind of tricky because it's 4x squared. It could either be in the beginning of the parentheses 4x times x or 2x times 2x. B is probably the easiest one, so maybe give that a shot for starters. Do the best you can, and I will see you in the next video.